If I take this second equation, 4 minus x is equal to y, I can say that x squared minus 1 is equal to 4 minus x. So x squared plus x minus 5 is equal to 0. So x plus 3 and x minus 2 is equal to 0. There's two different answers here after you factor it, so that's why the answer is C. Here they mention infinite number of solutions. So this would be 21x plus 7a. For infinite, you want the coefficients to match up and you want the constants to match up. So if you plug in a 2 for a, there would be infinite solutions. K is a constant, there's exactly one solution. Problem with 2, if we plug that in, these are equal to each other, so 2x plus 5 is equal to 2x plus 3. If you cancel out the 2x, there's no solution, so that doesn't work. A 5 could work though, so 2 only. If you distribute on the left and expand on the right by multiplying the binomials, this is what you get. The x squareds cancel each other out, and then we can move the 4x over here and the 1 over there, and there is one solution. If you distribute the 5, we have 5x plus 5 is equal to 5x plus 5. Cancel out the x's and the constants. 0 equals 0 is a true statement, so there are infinitely many solutions. We're told there's an infinite number of solutions, and this is one of the equations, so which one could be the other? So if we just double this whole thing, we would get 4x minus 6y is equal to 10. A. This is one of the equations and there's no solution. So that means the coefficients for the variables cancel each other out, but there's a wrong number over there for the constants. So if we took 2x plus 2y is equal to 2 and we slid this one in, 2x plus 2y is equal to 3, we can subtract straight down 0x, 0y, and negative 1. No solution. There's a solution where these cross. This one has two solutions. These lines, these little arrows indicate that there's two lines on top of each other, meaning infinite solutions. A is the only one where there's no solution because the lines never cross. We're looking for no solution. So first let's double this top one. So we have negative 6x plus 2y is equal to 12. The reason I did that is now the y coefficients match up. And we can see that if we make the x coefficients match up too, then everything will cancel out except for the constants and we'll be good. So if we put in a negative 6, then we subtract straight down all three columns, x's and y's go away, and we're left with a number on the right. Here's one graph. We're told that there's no solution, so we're looking for something that's parallel. And we're given ax minus y is equal to 1. If you look at the slope of the original graph here, we go up 5 and over 4. So our coefficient is going to be parallel with that for x. So we're going to choose 5/4 because the parallel lines have no solutions. Given that we have infinitely many solutions, what can we plug in to cancel out everything? I'm looking for clues to the 12 and the 60. We had to multiply by 5 to get there. I could from there figure out a and b, but there are going to be some decimals it looks like. 2/5 and 8/5. I can also just recognize what's the ratio between here and there. 2 over 8 is equal to 1 over 4, or 0.25.